Hello student, welcome to my YouTube channel Mathematical Corner. I am Mukul Sharma, subject sir. Today I shall discuss about trigonometric functions of sum and difference of angles. This is my lecture number 24 for class 11. Therefore, sum and difference of two angles or identities are cos x plus y is equal to cos x cos y minus sin x sin y. Cos x minus y, this is the difference of angles. Cos x cos y plus sin x sin y. Sin x plus y, this is a sum of angles. Sin x cos y, cos x sin y. And sin x minus y, this is the difference of the two angles. Sin x cos y and cos x sin y. Now, how can we prove this? That is proof number 1. We have to prove it cos x plus y. For this, we have to draw a circle. Let this circle is unit circle, and radius is 1. That is radius is 1. Therefore, we have to take a point P here. A point P1 here, a point P2, P3 here. Point P1, we put P1 point in such a way that so that this angle POP1 is x. We take POP1 is equal to x, and another angle is we take P1OP2, this is y, and clearly these angles will be x plus y. We take another angle P3 POP3, this is such that y, this is minus y, this is y clockwise anti-clockwise direction, and we take the same angles y angle here, but it is clockwise direction, so magnitude is same but direction is reversed, therefore it is minus y. Now, since it is an unit circle, therefore coordinate of P will be 1, 0. For coordinate of P is equal to P 1, 0. Now what is the coordinate of P1? Coordinate of P1, that is, it makes an angle x with OX. That is, coordinate of P1 is equal to P1 is cos x sin x. That is coordinate of P1, that is cos x and sin x. Yes. Now what is the coordinate of P2? We have to on the angle here P2 POP2, which makes an angle x plus y with OX. Therefore, coordinate of P2 that is cos x plus y sin x plus y. That is. Now, what is the coordinate of P3? What is the coordinate? P3 makes an angle minus y with OX. It is clockwise direction, so coordinate of P3 is cos minus y sin minus y. Yes. Now we join P1 P3. Yes. Now we join P1 and P3. P2 and we join P1, P3 and P2. We join. Triangle clearly. Triangle O P1 P3 O P1 P3 congruent with triangle O P2 P O P2 P. So the radius is same. OP1 is equal to OP2, OP1 is equal to OP2, OP3 is equal to OP, and angle is same in magnitude y. Therefore, two triangles are congruent. So, by CPCT, we can write therefore P1 P3 distance equal to P2 P. Now we should have to apply distance formula to find the distance between P1 and P3. Coordinate of is cos x sin x. This is cos minus y, sin minus y. This is cos x plus y, sin x plus y, coordinate. Now this P1 P3 distance, this implies we can write the distance between P1 and P3, P1 and P3. This is cos x minus cos minus y whole square plus sin x minus sin minus y whole square. This is formula is equal to, this is cos x plus y minus 1 whole square plus sin x plus y minus 0 whole square. This is the distance. P2 P3, this distance formula, therefore this is formula. P1 P3, this is. Now we simplify it. Cos x, since cos minus y is equal to cos y, therefore this is cos y, cos whole square. This is sin x, since sin minus y is equal to minus sin y, therefore this minus sin will be positive. This is sin y whole square, and this is cos x plus y minus 1. This is sin x plus y minus 0. Now a minus b whole square formula, we have to split it with the help of a minus b whole square formula. This is cos square x plus a square b square twice cos x cos y. This is formula. A square, this first term square, second term square, 2 into first term second term, and this is also sin square x sin square y plus 2 into sin x sin y, and this is cos square x plus y plus 1 minus 2 into cos x plus y into 1, and this is only sin square x plus y. Now we know cos square x sin square x, this is 1. Cos square y, this is sin square y, this is also 1, and from this and this, if we take 2 as common, minus 2, is common, minus 2 is common here, cos x cos y, minus 2 is common, therefore it is negative, sin x sin. Here also cos square x plus y, sin square x, this is 1, this is 1, this is 2, cos x plus y. Now we can say 1, this one, 1, this one, and minus 2, minus 2. From this we get cos x cos y minus sin x sin y is equal to cos x plus y. Therefore we can write cos x plus y is equal to cos x cos y minus sin x sin. This is the proof of 1. Now we can easily prove the number, proof 2, putting y is equal to minus 1 in 1. If we put y is equal to minus 1 in 1, then 1 implies cos x plus minus y is equal to cos x cos minus y sin x sin minus y. From this we can write cos x minus y. This is cos minus y. This is only cos y. This is cos y. Cos y is even function. Therefore cos x, this is simply cos y. But sin, in case of sin minus y, this is sin x. This is minus. Therefore it will be plus. Since cos minus y is equal to cos y and sin minus y is equal to minus sin y, so we can easily prove that. So proof number 2. Similarly, we can prove sin x plus y and sin x minus y. Now we can prove sin x plus y. Now we have to find out sin x plus y from cos x plus y. Sin x plus y, that is cos pi by 2 minus x plus y. Since sin theta is equal to cos pi by 2 minus theta, this is we have already got in class 10 standard also. From this we can write this as pi by 2 minus x minus y bracket. This is. Now we apply the formula cos x minus y. This is x minus y. Cos x minus y, cos x means cos x cos y. This is minus, there is a plus sin x sin y. Cos 90 pi by 2 minus 90 minus x, therefore it is sin x cos y. Sin pi by 2 minus x, that is cos x sin y. Again, putting y is equal to minus y. In this is 2 into we have sine x plus in place of y we put minus y to get sine x minus y formula. This is sine x cos minus y plus cos x sine minus y. Therefore cos minus y is equal to cos y. This is an even function. Therefore sine x, but this is cos x, this is sine minus y, this is minus sine y, this is minus sine y. Therefore write cos x cos y minus sine x cos y minus cos x sine. This is all about the formula about sum and difference of trigonometric functions. In next class I shall discuss about more trigonometric identities. So for today I have stopped it.